So in addition to using our Markdown to make our results more presentable, we can also use our Studio projects, which allow us to manage large projects with a lot of different files and different folders in a much easier way. So projects are useful because they define a project root folder for us. And whenever we open the project, this root folder will be the same. They allow us to save to our Studio environment that is unique to each project. So for example, libraries that were already called or data that is stored. And they also allow us for easy version control. And we'll talk about version control in a minute. So let's talk about our the benefits of a root folder. So instead of having to set the working directory and then using very convoluted file paths, if you have a large project with several folders that all contain different parts of the project, it would be nice to just being able to address them using relative file paths. And for example, let's say we're working from the subfolder code. Using a relative file path would then just mean go back to the root folder and from there go into the data if we want to, for example, read a data set. Instead, if we don't have that, we would always have to specify the absolute file path from the user folder all the way to the data folder where our data is located. So if you want to create a RStudio project, you go to File, and then you just simply start a new project instead of just starting a new R script or an R Markdown script. RStudio will then ask you whether you want to create a new directory or use an existing one, or if you want to create one using version control. And in general, you should either create a new one or you should use one with version control, and we also talk about this shortly. And this directory will then be your root folder, and everything within that directory will then be part of your RStudio project. So for example, here's an example of how you might want to structure your folders. You might want to have a subfolder for code. Within each, you will have, for example, a subfolder for all the files that help prepare your data, and one where you actually analyze the data. Then you have a data subfolder where you have the raw data and all the data sets that are created from the raw data. And then you will, for example, have document folder with reports, presentation, and images and figures also separately. And it might be useful really to have these relative file paths because you might be in the data preparation. You might want to get the data from here and then save the resulting data set in the derived data. So every time you want to slightly change the file path, and using relative file path makes it much easier. Another concern is that when you're working on a large project, that this project might be kind of sensitive to changes in like certain R packages. So for example, functions might get discontinued or something else might change. And in that case, it might be useful to just keep an older version of your package around, or in general, just keep all the libraries that you have been using when you were running your analysis so you can later reproduce it. And in projects, you can do that using Packrat, and Packrat basically creates a package library that is specific to the individual project. So you would just kind of combine all the libraries that you're using for the project into one project-specific library. Another version that allows even more flexibility is Docker, and we will not have time to go into these software in depth, but it's good to know that it exists if you ever need to keep track of exactly what kind of environment you're working with. Now, version control is something that is super useful if you're working on a project that is even slightly more complex. The downside is that the learning curve is relatively steep. So as long as you're just working, let's say, on your bachelor thesis and you have 2 R scripts and 2 data sets or so, it will most likely be a lot of learning for relatively little benefit. But as soon as you go slightly beyond that, version control might come in very handy. And as soon as you go to projects with multiple contributors, it's absolutely necessary that you use version control. I mean, from personal experience, I've once worked on a small computer game. We were 4 people, and even that small computer game were like thousands of lines of code. And without version control, it would have been absolutely impossible to keep track of all the changes and all the conflicts that arise when 4 people are simultaneously working on a project. So version control allows you to see the entire history of all the changes that you made to the files. It allows you to annotate changes, so you can write comments of what exactly you changed and why you did that. And it allows you to go back to previous version of the project. So the most popular software for version control is Git. Another version is Subversion. And Git allows you to, first of all, allows you to keep track of your changes to your project locally. You can also then synchronize this with GitHub, which allows you to synchronize your local changes with an online repository where you have stored a version of your project. So once Git is installed, you can use Git within the projects that you're starting. So when you're starting a new project, you create a new directory, and then RStudio will ask you whether you want to create a Git repository. And a Git repository is essentially a folder that tells Git that tells Git to keep track of changes that happen within this folder. So obviously Git cannot keep track of everything you're changing on your computer, which would be very inefficient and wasteful. But as soon as you initialize a Git repository, Git knows that it should keep track of what is happening in there. If you create a project by creating a new Git repository in RStudio, then Git will allow you to keep track of this project locally through RStudio. And in addition, you can also back up the history of these file changes using GitHub. And basically what you're doing, you're keeping track of the changes locally. And then as soon as you would like to synchronize it, you push all the changes to your repository where you keep an older version of your project. It updates the version of that project. And then, for example, later, if somebody else works there on that project and you would like to continue, instead of continuing with your local version, you take the updated version online back to your computer and then continue working from there. So let's maybe quickly take a look how this looks like in RStudio. So here I have a RStudio project, and what I'm currently working on is the instructions for module 5, and you can see it requires quite a lot of different data. I have a bunch of different data sets here. I have the instructions. There's a README. There is a there are also the code books and everything, and all these files are part of the RStudio because they're in this directory I created for this project. Now, for example, if I change something in here, so let's say I add another code chunk here. Let's just do something similar. Let's just print the working directory, get to the working directory. And we see that this works. And now I save this. Now you can see on the side here, it showed me that I made a modification to assignment 5 to the R Markdown file. So now if I would like to keep track of this, so like save this intermediate step using Git, I can highlight this, and then I can say I would like to commit this. And now I can just say, okay, I add a comment here, print working directory, because that's the change that I made. Commit this. close this. Now if I click here on history, you can see like all the changes that I've made so far, and here is the current change that I made. And all these steps are previous version of the project. So if I would like to go back to the previous step, I can now do that. So close this. So for this, for assignment 4, you will need a GitHub account because the assignment will be only part coding and the rest of it will be you checking out the data and the code from my GitHub repository, taking it into your own GitHub repository, and then copying it into your RStudio. Then you solve the assignment in RStudio, and from you will push it to your own, and then send me a notification that tells me that you have completed it, and then I can look at a preview of your assignment. So if you want, so first of all, of course, you need to create a new repository in your GitHub account, and you do that by clicking on the plus sign on the right side, and then it will allow you to create a new repository. From there, you tell GitHub how you would like to call your new repository, whether it should be public or private. And if you're using a free version, it only allows you to make a public repository unless you have an education account, which you can get if you use your university address to sign up. And then you initialize your repository with a README. A README is just a short description of the project. In RStudio, if you want to connect RStudio to your GitHub account, you do that when you initialize the project, and you create a new project, and then you do that using version control. And instead of creating a new directory, this tells RStudio that you would like to copy a directory from online and just make a local copy on your computer. And then you just choose Git and copy the URL from the repository, from your GitHub repository, and they will then make a copy from that locally on your computer. And what I just showed you before in RStudio is that how you keep track of changes. So whenever you're making a commit, that is basically an update that tells Git that you changed something that you would like it to keep track of. And you, in the Git tab, you can see all the files that have changed. So before we saw that we changed something in the markdown file, so it appeared with this blue M for modified. And then you can just stage all the file, or click on all the files that you would like to update using Git, and then you commit them and write a comment that tells you exactly what you did there. So here again, you can see how this looks like. And yeah, the blue M tells you that you changed something there and that you should probably commit these changes. So all the commits that you do, they will also only be saved locally. If you want to synchronize it with a remote repository, for example, on GitHub, what you would do is you would, after committing, you would click push, there's a button right next to it. And push means it will just take the current version, the updated version of the code that you, for example, copied from the online repository, and then push it to your online repository and force the online repository to update everything so that it is synchronized with what you have locally. And if you later, for example, if somebody else is working on it, and later you would not like to continue with the stuff that you have locally, but with the updated code where somebody else has been working, then you would pull the latest version from your online repository to your local files. Yeah, you can also view all your previous commits in the history, and if you have written helpful comments, then you can just see step by step what you changed at each step, and you can also revert changes with Git. So the last thing is that when you would like to contribute to an project, an open source project, for example, that is online, or in the assignment where you basically would pretend that you want to contribute to my project, you are going to fork a repository. So you will go on, for example, on my GitHub repository, where I gave you a link in the assignment, and then there is a button for fork. And what this does is it takes my repository, which is public, and creates a copy of that in your repository. And once you have a copy in your repository, you can then just use this. You can use that to create a new RStudio project with version control. You can work on it. You can commit it. You can push it to your own copy of my project. And once everything is done, you can send me a pull request. And a pull request basically tells me that you would like to contribute. And in the case of the assignment, this will be you will update the code that I have already started, and then I will see what kind of changes you made, and I can basically that way I can see whether or not you solved the assignment. So I will get like a preview of all the changes that you made. This will be the way to hand in the assignment for.